Hello, and welcome. So, we have an exciting tutorial for you today, and we're going to be talking about pointers. And pointers is something that is really one of the features that's really powerful about C, and it's also something that can be very confusing. So, what I plan to do is to provide about 3 tutorials on pointers. So, we're going to be talking about pointers, just the basic concepts right now, just the fundamental concepts. And later on, I plan to make some other videos that will cover arrays and pointers, pointers to structs, advanced use of pointers, dynamic memory, so on and so forth. So you may remember from our past videos that we used the address of operator in some instances. For example, when we do scanf, when we get input, we call the function scanf and we pass our variable with the address of operator. Well, there's a reason for that. That is because we're actually passing a pointer to scanf. We're passing the address of the variable. And so then that means scanf can take that address and place something in there, and when the function comes back, we have the value stored in that variable. Because remember, when we call functions, we normally pass our variable by value. It means they're copied. So if you change the value of the variable inside the function, it won't affect the variable. But if you pass it as a reference, you will be able to change the value. So when it returns, when the function returns, you will actually have the value stored in that variable. So let's start with this. Let's start with scanf. And of course, we have to create a variable. For now, let's just create a simple variable I. And let's initialize it to 0, even though we don't really have to. And let's get rid of hello world here. Let's go ahead and output whatever we read in. And remember, we have to pass the address of. So right now I'm passing the value. So what we want to do is we want to actually pass the reference. So we need the address of operator. That's the ampersand, and we pass the address of operator. And we run it. And of course, I didn't place a prompt. Just remember, always place a prompt, because like in this instance, I didn't place a prompt. So place a prompt, enter a value, and it displays it to the screen. So, and I know you've already done this, so let's just place a prompt really quick here. And let's not forget our new line feeds, our escape character, /n, and our semicolon to terminate the statement. So now we enter a value and it prints a value. Very simple. So scanf is probably on the other end, it's written in a way that it accepts a pointer. I don't know, I haven't even bothered looking at it, but I can imagine. How do you declare a pointer? Well, not by writing out pointers. So the asterisk is what you do. So you type in the type with an asterisk and then a variable. So it's very common to use the P as a prefix for the variable. So in this case, we're just going to say P just to keep things simple. Let's go ahead and display the address of P. And the way you do that, you actually have to use this hashtag or pound and 010 and then the X, and that'll give you the address. And the address that you see it's actually a hexadecimal value, and it's just address in memory. So it's just the way that the system addresses memory, and you're going to see the address of the pointer. But actually, that's not what we want to see. We want to see the address of I, but we want to see the value in P. Remember, P is already storing an address, so you don't have to use the ampersand for P. You just display the value stored in P. And let's put a new line so we can more clearly see side by side the addresses. To make this more interesting, let's go ahead and point P to I, and you will notice that the address of I and the value in P will be the same. And you notice they are the same. So the address of I and P, because P is now pointing to the address of I. So that gives us access indirectly to I through the pointer P. What if we added a variable, J in this case, let's go ahead and set our J. And you notice that we have an address for J and an address for I, and they're different. If you notice, you'll notice that they're 4 bytes apart. So if you notice, J is B0 and I is B4. That's 4 bytes separating them. And they don't necessarily have to be, they just happen to be in this case, but you remember a pointer, depending on the type that you use, int, float, double, long, whatever, it's going to know how many bytes it uses to address memory. So in this case, let's point it to J, and we can see the example. Let's take another pointer, P2, and point that also to J. So now P2, P, and J should all have the same address. And you notice that J, P, and P2 all have the same address. Let's adjust our spacing so we can see it better, one below the other. You notice that they all have the same address. That's because they all point to the same location. So they're using the same memory space, so they're not having memory space. So if you actually change that memory space, the address will remain the same, but the value stored in that address space will change for all 3 values. And we can go over that in just a second. Let's create a function to receive a pointer. Let's create the function change value, and we can accept a pointer so that I can demonstrate how you can actually change a value within the function, and when it returns from the function, the value will actually be changed. So keep in mind that normally when you write a function, if you don't use pointers, typically you're passing a value. So you're actually, it's making a copy in memory and sending the value. So, but it doesn't necessarily know where that value originated from. All it knows, it has the value 1, 2, 3, 4, 5. Whatever you're passing, it just has that value in that function. So for example, here we say don't change value. Even though we change it in the function, you notice that when it returns, it's still going to return with the original value. Now let's make this a little more interesting, because 0 times 2 is 0. So let's change it to 2, and let's change it to 2 as well. So it should actually return 4, but you will notice that it won't do that. Don't change value, even though it really does change to 4 within the function. When it comes back from the function, it will have still 2, because it has not changed. They're 2 different variables. They're separate, and it's separate places in memory that are being changed. So you notice that it's still 2. It didn't change. So if we write another, if we update the other function to change the value, you can see how we can assign a value. Now it's kind of interesting the way you change a value to a pointer, because now since the pointer actually has the address, so there's something special that we got to do in order to change the value. And what we have to do is use the asterisk to precede it in order for it to understand that we're actually changing the value that the pointer points to and not the pointer's value itself. So we're not changing the address, we're actually changing the place in memory that the pointer points to. And it's the same way to assign and also to get the value, to extract the value. So we're going to have to do the same thing to p-val here in order to multiply that value times 2. And once we do that, you will notice that after we call this function, it will update it, and now it will say 4. So now we actually change the function call to change value. We pass it, but now keep in mind that we're passing a reference, so we have to use the address of operator because we're passing the reference to I, not the value of I. And you notice that it changed to 4. Let's adjust this so that it reflects the true statement. So now the value is 4 because it changed the value. Now you may wonder, why is this important? Why do I need to pass references? Well, keep in mind sometimes that you may actually have to pass the reference because maybe you have multiple parameters and you want to be able to pass by reference so that those values can be changed. Because remember, a function can only return one value back. Well, what if you had 2 or 3 or 4? And I will demonstrate that in a second. So let's create another function, and for lack of better name, let's just name it foo. And here's something that you don't want to do. So here I'm declaring a variable and return the address of, you don't want to do this, and I don't even think it'll let you get away with it. You don't want to do that. And of course I have to change my return type. The void's not going to work. I have to actually return a pointer to an integer. So you may be wondering why this is important. Sometimes you may need to return multiple values from a function, and when you do, pointers is a way to get around the single return from a function. Remember that a function can only return one value. Now it can be return any type of value, but sometimes you need to return more values, or maybe you need to just change the values and you have multiple parameters. So a way to get around that is to pass pointers. So let's create a function here, get name, and we're going to use several parameters. Let's change the function name to something more interesting. So let's just get info, and let's use our famous variables x, y, and z, and they have to be pointer types. So we use the asterisk. And notice that I actually assigned it different ways. And one, I did it right after the data type, and in the other case I did it just before the variable. It doesn't matter, you can do it either way. It's just a matter of preference. So now we can change the values, and let's add a comment, and let's use the proper comment, because the other comment is accepted, but it's not necessarily part of the standard, so your compiler may or may not recognize it. So now we're going to assign 5 to the location that x points to, and let's assign 10 to whatever y points to, and let's do the same thing with z. Now z, we'll make it 15. And notice that I'm using the asterisk, so I'm assigning it to the value. If I was to just not use the asterisk, it would actually be assigning an address. And I don't even think it would take it, but it wouldn't necessarily take 5 as the address, because who knows where that's pointing to. So let's go ahead and call our function with the three parameters. And remember, we're going to have to pass three parameters, so we need one more variable. So let's just do k. And notice also that I'm not using the same names for the function as I am for the variable, so they don't have to match. As long as the data types match, that's what matters. So I pass it the address of I, the address of j, and the address of k. And let's go ahead and display the values by using our common printf function. So let's go ahead and do a new line, and so the values of I, j, k, and let's use our %d. And notice how I changed the values of I, j, and k by passing the address of. So I'm getting three return values, and in essence, three return values. It's not really returning anything because the function is void, but I'm actually modifying the values of three different variables. And when we run it, we can see that I, j, and k will have the values that I assign in the function, and you can see I, j, and k have 5, 10, and 15. Sometimes you may still want to pass by reference, but you may not want whatever function to that you're creating to actually change the values of the variable. So for example, you can pass still by reference. Keep in mind that right now you're just learning fundamentals. So if we use const int pointer, you can't change the value of p. And so you're still passing by reference because that may help you save memory. Now remember, you haven't got to the point where with more advanced uses of pointers, so you don't get to see the advantage right now. But just keep that in mind, because when you pass really large data structures, you may still want to pass by reference, but you don't want to do that. And you can see it gave us an error because it wouldn't even compile with that. So you can't change the value when you declare a constant. You may not want to change it, so you want to let whoever know, whatever function, that hey, don't change my value, you know. Let's get rid of foo. Okay, that was a warning. That was just foo was just a warning, so it didn't reveal itself until we had this error. But still, it doesn't compile because we're trying to change the value of a constant. Now we can point p to something else. We just can't change the value that p is pointing to. This approach also lets the users of your functions know that you're not going to change their value. So it's important to have that constant. If you don't intend to change the value, it's important because it lets the users know that you're not going to change this. One thing that I didn't mention is that you can use pointers of any type: float, short, char, anything that you really want to use. And so even your own custom data types, you can have pointers of that type. So you can really use it for any type. Now we haven't gotten to the more advanced concepts like structs and user-defined types, but just keep that in mind. Now keep in mind that you can also, like in this case, we can change p, what p points to, and it'll compile fine, but it doesn't really matter because p is not being returned and it's not doing anything. There's also the concept of pointers to pointers, in which case that would change things a little bit, but we won't discuss that until we get into more advanced uses of pointers. Well, I think I've covered everything I need to cover for now for your introduction to pointers. Hopefully you got something out of it. If you have any questions, just make sure you place your question in the comments below. If you like this video, go ahead and subscribe. And remember, until next time, where I'm going to make more videos. So please make sure to subscribe, come back and visit, and you will get to see more advanced uses of pointers. Thanks for watching.